Very good morning, my dear friends. Myself, Dr. M. Chennaiya, and in today's video, we are going to study the development of the lateral surface of a tetrahedron, which is cut by a section plane, which is normal to VP and parallel to one of the triangular faces. So, we will first of all write down the top and front views of the tetrahedron given. The side of the tetrahedron is 40 mm. So friends, let us mark XY line, mark VP and HP indicating first angle projection, and here we'll write down the top view of this tetrahedron, which is an equilateral triangle of side 40 mm given in the question, and we will number or name these corners as A, B and C. Here side AB, that's one of the side he says is normal to VP. I will say AB perpendicular to VP. Friends, let us locate the center point of this equilateral triangle by drawing the lines like this. So if you draw any two perpendicular lines to these AB and BC, you get O, the center. We will join O to A, O to B and O to C. These OA, OB, OC represent the top view of the three slant edges or three edges of the tetrahedron. Friends, let us produce all these corners A, B and C to meet XY at this point A dash, B dash and C dash. Here the line A dash, B dash, C dash represent the base or front view of the base on which the tetrahedron is resting. Friends, from here, from O, we'll draw a vertical line upwards. And here, friends, in a tetrahedron, all the edges are of equal height or equal length, and they don't give you the height. So we need to find out the height of this. How we obtain this height? That is from the tip of that to the center of the base is to be obtained. Friends, here you see OC is one of the edges. OC is parallel to VP, and from here I am going to write an arc having radius equal to 40 millimeter. If it is 50, we have to draw an arc using 50 millimeter radius. I'm going to join these, friends. So this will give you the true length of the edge or height you can obtain. This is 40 mm and this is O. We are going to join O to A, O to B. Friends, this triangle represents the front view of the tetrahedron, and this is the top view of the tetrahedron. Now friends, we will have to draw the development. For drawing the development, we need to have the true length, and all the true lengths here are same, but all the edges are having same dimension. That's equal to 40 millimeter. Now friends, I mark a point here, call it as O, draw a vertical line through that, and this vertical line will have a length is equal to true length. I will say this is also equal to true length, which is equal to 40 mm. And using this as center, this as radius, I am going to draw an arc. So on this arc, I am going to step off 3 times this 40, the length. So this is 40, 40, and say this is again 40. So I am going to join the last point to this. And friends, all these base edges are straight. So I am going to join it by a straight line, a straight line and a straight line. And also these edges which also measure 40. This is true length, is also true length. All these are true length only. Now friends, let us mark the section plane. It's cut a section plane normal to VP and parallel to one of the triangular faces at a distance of 20 millimeter from it. Friends, in the front view, the line O dash A dash B dash represents one of the triangular faces. There will be three triangular faces and it is one such. And the section plane is perpendicular to VP or normal to VP. Any section plane perpendicular to VP is seen as a line in the front view. And in this question, he says it is cutting the solid such that that section plane is parallel to OAB, the triangular face. So friends, I will just mark a line here parallel to this OAB, that is this line is parallel to this and at a distance of 20 millimeter, as given in the question. So the section plane is cutting the solid at a distance of 20 millimeter from this triangular face. So friends, you can observe here the solid is cut here by the section plane. This is on a slant edge, that is OC 1 point, and also it is cutting here the bottom face of the triangular surface. So there will be 2 points here and 1 point here. So totally you are going to get 3 points. Let's see friends, which portion of the solid is to be retained for development. Generally, the larger part of the solid is retained for development unless otherwise specified. So friends, I am going to retain this portion of the solid for drawing the development. So this part I am going to develop. We'll call it as P, that is the part retained for the development purpose. Friends, here we are going to throw away this portion. We draw the develop only for this portion shown in visible line or dark line. So friends, here we can start the development from OA or OB or OC. The choice is ours because none of these edges OA, OB or OC are totally removed from the solid. So I will start say from C, point C. This is going to be A, this point is B and this point is again C, A, B, C. Friends, now let us mark these points. This slanted OC is cut here. OC is parallel to VP and this will give you true length. So on OC, you can take this measurement and mark it straight. So this is one point here on OC, the other point say here. So we got 2 points on the OC. Base is cut here. Base is A, B, C. So to know exactly where it is cutting, I am going to draw a vertical line downward through that point. It is cutting AC here and also it is cutting this BC at this point. You know friends, AC, BC and AB, they are all true lengths. Now friends, we have to mark this point on AC. So on AC, say from C, take this measurement and mark on AC near to C. So you are going to get a point here. Similarly, on BC at the same distance from C, take this distance and mark on BC near to C. Friends, this distance and this distance are the same. Friends, let us join the points so obtained by straight line. So friends, I am going to join this to this. This is on OC. We will join here. We will join to this. And friends, these slant edges OA and OB are to be shown full. This is OA. and this is OB. And friends, the portion from A and B till this point should be retained. So I am going to show this by dark line. This is by dark line. This is by dark line. Friends, this figure, let me number the figure and then mark it. So if I am calling this as point number 1, this is point 1, this is 2, and this is 3. So on AC we have got 2. On AC you have got point 2. On BC you have got point 3. This is 2 comma 3. That is 2 comma 3 here. And finally you have got on OC 1. On OC is 1. 1, 2, 3. We joined all these points, and friends, this figure O13 BA21 and 0 will give you development of P, this part, development of this part, which is shown in dark lines. Friends, I hope the presentation on this tetrahedron development was interesting, and if you think that it is of some benefit to students doing their engineering degree, please share the information with all your friends and have a wonderful day.